Okay, so yesterday we learned about functions. Okay, so today we're going to be identifying functions. So let me just go back. So functions are a relation, but they're a relationship, but we'll call it a relation. And we learned that relationships are pairs of numbers, and we just look at all the pairs of numbers. Well, the functions are a special type of relationship. It's a relation where all x values are paired with exactly one y value. Okay, so when you have that little function machine, oops, we'll have the output come out over here. Okay, and you put something in. So say we put 8 in and we get 10. Okay, next day we come along, we put 8 in and we get 11. There's something wrong with that, right? We're putting 8 into the same machine and getting something different. Okay, so there's something wrong with that. This would not be a function because 8 is paired with 10 and 11. Okay, and so we're looking, when it's looking for a function, we're looking for a set of numbers where x is always paired with exactly one y. Okay, so what we noticed here, what we kind of got used to doing then is looking for repeats in the set of x values. And if we saw that, it kind of was a big red flag, a little alarm that goes off. Okay, now in some cases, it's well, all the problems are a little bit different. So I'm going to go through some various problems here of what this would look like. Okay, so we have the mapping and a table here, and so you kind of have to see. But if you don't actually read the problem, you could kind of get lost here. It says which of the following would no longer be a function. So that means that x will repeat if it's no longer a function. So we'll have an x that repeats. That's what we're going to be looking for. If 10 negative 6 was added, so that means that 10 has to already be a member, an x value of the domain. Remember, the domain is all the set of, here's the x. So 10 has to be a member. The domain is all of the x values. And so 10 is already going to be a member. So we're going to look at the x values and see if one of them has 10. So we look at A, we just look here. Do we have 10? No. So 10 won't repeat if I add that in. Look here. Is 10 already a member? No. So if I add that point in there and put 10 negative 6, I would still be a function. Okay. So I look at this domain, 10. Oh, yes, it is. If I added 10 negative 6, then I would have 10 mapped to negative 2 and 10 mapped to negative 6. Can't have that. 10 is already a member. I add 10. I create problems. C is no longer going to be a function if we add that point. And so there's going to be problems like that. And you notice the mixed, and there's a table and some mapping that goes there. Okay, so this one says which relationship shows y as a function. So that means that it is a function, no repeat x's. So we look at these domains. So negative 6 repeats on that. Can't do that. Negative 3 repeats on that. Can't do that. I'm going to look at the other table. Negative 1, negative 9, 8, and 1. Oh, that's a good one. Okay, so there's no repeats here. Why did I skip the other one? Because it's easier to see it in a table. So I was being lazy. 0, 10, 8, and 8. So there's our repeat. 8's our repeat. So I'm just double checking to see, make sure I didn't miss something. D is correct because there's no repeats there. So in this particular problem, we didn't have to actually add a point. We're just trying to identify which one it is. Which graph shows a function? Now this is the new part, okay? So which graph shows a function? Basically what's happening here is we're looking for one where x doesn't repeat. What does that mean? X doesn't map, there's that word, to more than one y. right? So we're looking for a function where x is only mapped to 1y. So I'm gonna do a couple of these. So what you do here is it's called a vertical line function test. Okay, so basically I'm gonna make a bigger vertical line here. Okay, so I take this vertical line and I'm gonna move it along. If this vertical line hits the line, which is pink, in more than one spot, well, here it's not hitting it all, right? My vertical line doesn't touch it. I go to here, it's meeting at one point, 1, 2, I believe that point is. So we're good. But as soon as we go here, we're hitting that vertical line at more than one point. I'm going to just pick that here. Okay, so when I take that vertical line and I move it along, it, boom, it hits right there. So let's look at those points. 1, 2, 3, 4. So that's 4. 1, 2, 3, 4, 5. This is 4, -1. You notice on that they both have 4? That's a repeating x value. That's what we can't have in a function. So what we can use then is the visual of a vertical line. If it hits the graph in more than one spot, here we're fine, but as soon as we get here, no. 4 is matched with 2 different y values. And every point from this forward will always have an x mapped with 2 y's. So that is not a function. So I bring my vertical line down here. Oh, look at that. It's hitting at 2 points. So do these two here. Okay, so it's hitting at 2 points. So I'm going to move my vertical line. Boom, hits. It's every point in line. What part of the line? We're talking about the pink line. The pink is not a line. The pink function or relation, graph, whatever. So it's hitting at more than one spot. So right there at -1 is mapped to 2 different y values. So we come down here to this one, and we have these weird values. These are all the way down here at the bottom, down here. Okay, so we have these weird things. So open circle means it's not a value there. Closed means. What you don't want is either two lines overlapping or two solid dots overlapping. So like right here, the vertical line is hitting only at one spot. I come here, but that's an open circle, so it's still only one spot. Now it's only one. I come here, it's still one open, one closed, so we're good. One open, one closed. So I never overlap on this one. Never overlap. It's never hitting 2 lines at once. So that's our function right there. Let's look at this one. I'd save this one for last because look here. It's not hitting the line, not hitting the line, not hitting the line. X isn't a value, and boom, right there. It's hitting every point. So if we look at some points on this line here, it's 1, 0, 1, 1. X is always, right? This one's a 1, 3. You notice how all the repeats in the X. So vertical line is not a function. Okay, so our answer here would be D. It's the only one that doesn't overlap at all when you're looking at your vertical line test. So this is our new one. So vertical line test is what that's called. So you could take any little piece of paper, ruler, whatever, and just run it along vertically to see if it's overlapping. Which is your choice of, above function. I guess we had, so we said D, each value X corresponds with no more than one output Y. Why is your choice above a function? Oh, a relation fails the vertical line test. There's at least one vertical line that contains more than, but there's at least one X value. Why is your choice above a function? Each X corresponds with no more than one Y. Okay. That was fun. Okay. Which relation is not a function? We've gone over that, and it's not a function. So we do have repeats. You have to really pay attention to that. So repeats, that's not a function. Oh, that was easy. I went to the easiest one. The rest of them don't have repeats. Okay, here's good. Okay, so this is what I was hoping for. So let me get my vertical line down there. Vertical line, you are needed. So vertical line test. Okay, does not show a function. That's so super important to read the problem. Does not show. So we're looking for one that does overlap. Okay, so anywhere along the line here with A, it's never hitting 2 points. C, never hitting 2 points. B, never hitting 2 points. But look here, this is the same thing we had on D. Okay, open, closed, uh-oh, closed, closed, boom, right there hitting 2 points because it's not following that open, closed. So D does not follow. That is not a function. Each input value corresponds to one output. There's at least one X value that has more than one Y value paired to it. That would be Y. One X value had more than one Y. Okay. All right, so which order pair could be included in the relation so that it remains a function. So no repeats, remains no repeat. Okay, so we have to look at the X's that we have and make sure we don't put one in. So -9 cannot be in there, 6 cannot be in there, 5 cannot be in there, so it is, because there's no 9 in that. And remember, we're only looking at the X's. And which order pair, another one of these, would cause it to no longer be a function. So would cause it to repeat. Okay, so you notice I have 9, 6, 0, and 4, so I'm looking for one of those two, 9, 6, 0, and 4. The other three don't have an X value that we already had. So which would cause it to repeat? The 6 would cause it to repeat. 7, we've done these enough. So function, if the point -4, 5 would still be a function. So you need to find one that does not have -4. So that has -4. Look at the X's, that has -4. Look at the X's, that has -4. Remember, I'm kind of cheating and skipping those ordered pair ones because process of elimination. So I just double check that. X is 7, 6, -7, 5. Yep, no, there's no -4. So that one we'd be able to add this to here and it would still be a function because there's no repeat. All right, one more graph, good. Okay, let me find my, just make another vertical line. So I make my vertical line and I do my vertical line test. Which graph shows a function? So we want a function, so we don't want an overlap. This overlaps. See how it's hitting at more than one spot here? Okay, so let's go ahead and try this one. Boom. See how it's hitting? These are both closed, so that's failing the vertical line test. Look at this one. Boom. Hitting at 2 spots, so that's not going to work. And boom, anywhere along here, not counting those arrows. We don't count the arrow. Oh, look, it's touching it. No, we don't count the arrows on the end. We just count this. Okay, so it's going to be D is a function. There's an input value. Oh, wait. There's at least one X value that has no. There's not a vertical line that would contain no. There's an input value corresponds with. There is at least one X value that has more than one value. That's not it. There's not a vertical line that would contain. There's not a vertical line that would contain more than one ordered pair. Okay, so any vertical line couldn't touch it twice. Okay, so let's see. Oh, goody, one more of these. Okay, so does not show a function, does not show a function. So it fails the vertical line test if it does not show a function. And this one down here, you can see fails the vertical line test because it hits more than one place. So it's going to be D and Y. Each X value has no more than one Y value. Well, no, that's not it because it's failing. So, oh yeah, the relation fails the vertical line test. So it's going to be B. All right, so there you go. That is how to do those. I know that's kind of quick, but that should help you with Get More Math.